Hello learners, in this video we will see how we can solve a problem involving work done or power when a body or an object is moving along an inclined plane. So in the question, a train of weight 1500 kilonewton 1500 kilonewton is ascending a slope of 1 in 100 with uniform speed of 36 km per hour. Find the power exerted by the engine if the road resistance is 5 Newton per kilonewton weight of the train. That is the question. Okay. So we need to find the power exerted by the engine. Power generated by the engine to pull the train at a speed of 36 km per hour to climb an inclined plane or inclined surface like this. So if this is the train, the engine has to put in some power so that this whole train will have a velocity of 36 km per hour. And this engine has to overcome a frictional resistance of 5 Newton per kilonewton weight of the train. Slope in the question it is given as 1 in 100. 1 in 100. That means for each 100 horizontal units or distance or meters, 1 meter height. That is 1 in 100. Let this be theta. Then tan theta equal to 1 by 100, or this can be written as equal to sin theta. How can we write tan theta equal to sin theta? If the angle is very small, then that means for 100 unit of distance 1 meter, horizontal distance 1 meter, vertical distance means it is a very small angle. So for very small angles, tan theta equal to sin theta, or sin theta is equal to here sin theta equal to 1 by 100. Okay, clear? So here sin theta is 1 by 100. Now in our problem, the train is having a weight of 1500 kilonewton. 1500 kilonewton, which is acting vertically downwards. So this is 1500 kilonewton. And as the train is going up the inclined plane, okay, this weight of the train is at an angle to the surface, to the plane. Okay, so we need to resolve into two components. We need to resolve into two components. That is, this component will be 1500 sin theta, and this will be 1500 cos theta. Okay, so this term 1500 sin theta will be equal to, by substituting the value of sin theta, we will get 1500 into 1 by 100, or it is equal to 15. It is 15 kilonewton. Okay, then what is the resistance? If the engine has to pull the train up, the frictional resistance will be in the downward direction. So this total frictional resistance is equal to how much? 5 Newton per kilonewton. That is, so F, the frictional resistance F is equal to 1500 into 5. Isn't it? For each kilonewton weight, 5 Newton is there. So it is 7500 Newton. Okay, 7500 Newton is the total resistance. Okay, so I'll draw the free body diagram for the train which is moving up the plane, that is, this is 15. It is there, that is actually not needed because we need not calculate the resistance, frictional resistance. We have, it is given in the question as 5 Newton per kilonewton, 5 Newton per kilonewton. Therefore, it is this is 75,000, 7,500, 7,500, and P in the upward direction. Okay. So along the plane, the forces are, as the train is moving with constant velocity of 36 km per hour, the net force acting on the body or the train is 0. That means sigma F equal to 0. That will give you the net force acting on the body is equal to 0. And this 36 km per hour in meter per second, it will be 36 into 1000 divided by 60 into 60 will be equal to 10 meter per second. It will be 10 meter per second. Okay. So the net force acting on the body is sigma F equal to 0. The net force is P in the same direction of motion taken as positive minus 15 minus 7,000 7.5 kilonewton. Kilonewton, it is 15 is kilonewton. Therefore, I will write it as 15,000 minus 7,500 P minus 15 minus resistance equal to 0. P minus 15,000 minus 7,500 is equal to 0. So, P equal to 22,500 Newton. 22,500 Newton. So, that is the force required for the engine to pull the train up the plane, up the inclined plane. Therefore, power generated is equal to the force P into velocity. That is 22,500 into 10 is equal to 225,000, and that is equal to 225 kilowatts. 225 kilowatts is the answer.